Hi guys, it's teardown time and testing time. Well, of course, what it should be. Of course, it's a high voltage power supply. I bought this power supply, I think 2 or 3 weeks ago from a local auction. When I saw it, I liked it immediately because I was looking for a reference for a tube power supply that I can use to test against my DC to DC tube power supply that I'm designing in means of noise and EMC, etc. I was looking for a heath kit, something linear, yeah. But I don't know. People are crazy. These heath kits are going up like crazy, yeah. Who needs that? Anyway, I found this INNOTEC. I never heard this company before, for very low price. It is, the data roughly are 0 to 500 volts, 0 to a half an amp. That means it's a 250 watt analog power supply. It has overvoltage, not overvoltage, overcurrent, overvoltage. You can adjust it here. Let me see if I can zoom that. Yeah. The thing is, this is a design from the 80s, probably early 90s. You can activate the overvoltage protection with this. You adjust it with this potentiometer, and when you press that, you will see what you are adjusting here. And you can activate the output on and off. Yeah, you have two different switches. Interesting, yeah. And over temperature you have here. That's all. Then you have the 0 to 500 volt. It's a 10-turn potentiometer, and 0 to half an amp. It's a single-turn potentiometer. That's it. And a dedicated clickety-click mechanical switch. Yeah, this video we will test it, and I will make a teardown. It's German engineering from the 80s, late 80s, mid 80s, early 90s, something like that. Yeah, it is heavy, linear. It has a Torodial transformer. So I'm expecting good design, good German engineered design. Let me show you a little bit more of the specifications. Okay, this is the spec sheet. This is everything that I found. I didn't find more information about this power supply. Just make it a little bit bigger for you. You can read it. The specs. It's perfect. It's load regulation, a very good load regulation. Ripple, 20 millivolts, less than 20 volts, peak to peak. Okay, that's not that good, but anyway, yeah. This is the product description in English and in German. I will leave it a couple of seconds for you to read it. So you can stop it and press pause to read it. Input specs, safety specs, and that's it. And that's the company that made it. Yeah, okay, let's open it. So this is how it looks open. Yeah, I will give you my opinion about the construction in a jiffy. You can imagine it's not the best one. To open this thing, you have to put it, the power supply, turn it on its head, loosen these two bottom screws on both sides, and then you normally would get, you can remove this cover, but it's not possible because you have to loosen the top screws too, here and here on the bottom. I I had to replace the plastic cover of the fan because it was covering the bottom screws, the top screws of the casing. Well, that's the first fail. Yeah. Anyway, otherwise I could not remove this thing. It was stuck. So, let me show you more details. First of all, this design is full of bodges and bodge wires and things that have been done later. Look at that. This is full like that. This should be a professional design. All the cables are not locked. With vibration, they get loosened. All of them. Stiff cables, unnecessary, big, thick cables. They could have used a totally different GSD or something else with much more flexible cables. This is all of these connectors here are not locked. They're just pushed on the headers, nothing else. Yeah, anyway. Yeah, at the beginning I thought these are microcontrollers. Of course not. This is a design of the 80s, totally analog, what is good. I have no problems with analog because it is quiet, noise-free, or at very, very low noise. They're using the ICL 7107 2 times. The second one is here. As a 3.5 digit driver, analog to digital converter, and driver for the display. That's all. What I don't like is these bodges here, everywhere. Second thing is, how do you remove these MOSFETs? When these MOSFETs here, how do you remove them when something happens? It seems they have anti-seize everywhere. That's okay. That's for temperature control. There are 6, I don't know if they're MOSFETs or transistors, power transistors, but there are 6 of them. You can see it here. The problem is, this thing is really awful. Look at that. Everywhere bodges, 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 and what is that? What I see here. Whoa, what a nice soldering. Whoever did that, great soldering, congratulations. I hope this is not from the factory. Anyway, this is not a good design. Totally crowded, cramped together. Everything is touching here, even this metal part here, it's already touching. The filter is touching already, the transformer. No, sorry. Here, they could have used another connector and not solder it. I don't understand. Anyway, I expected something different when I opened it. Here's the power switch, mounted on 2 screws. Yeah, typically construction of the 80s. This metal rods, back to the Tektronix oscilloscopes. Anyway, yeah, we have some reefer capacitors here. Okay, that's not the problem. Mechanical, I don't know the electronics. It is like, look at that, it is everywhere botched. Everywhere. see it here. Let me see if you can watch it better. Yeah, of course, this is exactly the problem here. It's not that easy to get out these components. You have to dismantle everything. No. Anyway, yeah, I don't like it. Unfortunately, yeah, this is the same thing here. Look, they had to put an isolation tape so the road does not damage the transformer. Yeah, well, that's not a nice design. Anyway, I will put it together. The thing is that I have seen many of these complicated designs like that. Look at that. The cable goes merry-go around, and this is the no. This is the strength relief over the capacitor. Really. Anyway, I've seen many times such kind of construction from the 80s, even from very big names in the industry. Mechanically catastrophic and overcomplicated. And this is not an exception. Bad solderings, look at that. Really? This is a factory stuff? No. The only good thing is that it is linear and it has good specs. I'm not sure if I want to repair it, if it goes. If it dies, probably I will take out the transformer and redesign it with a similar concept, but not like that, in another casing. Anyway, let's continue. So, that's the transformer. Really nice transformer, big one, heavy one. This was, of course, the most heavy thing in the power supply. And as we can see here, we have 3 center tap 79-volt windings, each half winding of 1 amp. That means there are 6 windings and there are 6 MOSFETs or whatever it is, transistors. I think there are MOSFETs inside there. If you multiply it by 6, you get to 500 volts, more or less. Yeah. The 8 volts, I don't know what that is for. Perhaps they use it additionally. But anyway, from that, I think the output is like a cascade or a cascade output. That means they are switching electronically the outputs of this transformer through MOSFETs depending on the selected voltage. That's only a thought. If anybody thinks something better, let's just tell me. Because I do not think, first of all, there are no relays. I do not think they will use triacs. No, I don't think so. And the second thing, I do not expect that they put all these windings in series to have a big 500 volt winding and then just use the MOSFETs as a big regulator element. This would be the most inefficient way. So this is why I think, this is my opinion, they're making because this is why there's a lot of electronic in the control. They are switching the MOSFETs, where they are switching the outputs, the rectified outputs of this windings here through the MOSFETs to the output, depending on the selected voltage. Yeah, well, this is what I wanted to show you. Just give me your opinions. So it's time to test the power supply, the INNOTEC power supply. For that I'm using my simple 200 watt up to 1 kilovolt IGBT based dummy load that I built many months ago. I've a dedicated video about that. Let's have a look. So let's turn the whole thing on. And let's see how good we are with the output voltage. At the moment we have nothing. Let's get on and let's see what we are doing. 188 and my voltmeter says 187. It's not really bad, to be honest. Let's go higher at 250, if it's possible. Yeah, 250, 250. Nice. And let's go maximum now. 528, 528. Let's turn down the current. Here we have a maximum, and let's turn it on. And let's see. We already have 4 milliamps, but I do not really believe that. And interesting. So now we see on the display on the left it says 52 milliamps. I see 47.9. Anyway, let's go higher. That's 100 milliamps. And I see 69. Yeah, okay, we are there. It's getting warm. Nothing is getting warm. I will go up to 200 milliamps. And this is where I think I will stop. That's more or less 100 watts. Let's go a little bit higher. It's starting to get warm. Let's go at 300 milliamps. The power supply works nice. This is, of course, yeah, the load is not made for that. It was made for 200 and absolute maximum, yeah. But yeah, and the plan is to make it another load that goes way higher. I don't know, probably 1.5 kilovolts and up to 1000 volts, 1000 watts or something like that, yeah. And the whole thing will be water cooled, but this is a project for another day. Anyway, this is how it looks, how it works. It is a design of the 80s. It's a lab power supply, and the mechanics are awful, catastrophic, but the whole thing as it is, if you do not open it, it's okay. Unfortunately, I have other than what I showed you, this data sheet or the fact sheet or however you call it, there is no other information on the net I have found for that. But it works, and this will be my reference to compare it for the DC high voltage power supply I'm preparing. So guys, if you like what you see, if you like my videos, give me a thumbs up, or two, or many, yeah. Press the notification button and please subscribe to my channel. That's for today. Thank you for watching and see you next time. Stay safe, my friends. Cheers.